Good morning, children. Welcome to our chemistry online class. So, we are continuing our revision. Today, we'll discuss some questions from the chapters 1 to 6. From the second chapter, the structure of atom, you can expect questions based on quantum numbers. We know quantum numbers is the address of electrons. Using these quantum numbers, we can define or we can identify where is the presence of electron. It is the address of electron. So we know there are mainly 4 quantum numbers: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Principal quantum number represented by the letter N, azimuthal lambda or L, magnetic quantum number by M and spin quantum number by S. Principal quantum number is the specifies the main energy level, that is our K shell, L shell, M shell and N shell. It is the main representing the main energy level, that is orbit. Azimuthal quantum number give the information about the sub energy level, that is S shell, P shell, D shell and F shell, that is giving the idea of orbital. And magnetic quantum number is giving the idea of spatial orientation, how an electron will orient, how it will degenerate. These all things given by the quantum number, magnetic quantum number. And spin quantum number is the movement of electron, which direction the electron is moved, either clockwise or anti-clockwise. These are the main 4 quantum numbers. So, this is one of the type of question you can expect for the examination. That is, an electron is one of the 3D orbitals. Give the possible values of N, L and M. Here representing N, L and M are our quantum numbers. N is principal, L is azimuthal, M is magnetic. So, from this idea, we should deduce the answer. Hence, it is 3D orbital. So, this 3 is representing the main energy level. So, the principal quantum number N is equal to 3. If it is 4s, its principal quantum number is 4. N is equal to 4. And possible values of azimuthal quantum number. Azimuthal quantum number was given by the formula n minus 1. That is, if principal quantum number is 3, azimuthal quantum number is 3 minus 1, it is 2. And possible values of the magnetic quantum number, that is minus L, 0 to L, like this manner. So, if you take L is equal to 2, minus L equal to minus 2, 0 and 2, this one. So, minus 2, minus 1, 0, 1, 2. These are the magnetic quantum number. Spin quantum number having only 2 values, plus half and minus half. So, the relationship between N and L or N and L or N and lambda, that is principal quantum number and azimuthal quantum number, is given by the formula n minus 1. If n is equal to 1, L will be 0, that is n minus 1 will be 0. If n is equal to 2, L is equal to 0 and 1. That is, it's having 2 values, that is 2. If n is equal to 3, the values will be 0, 1, 2. And each pair is representing 2 electrons. Next one is magnetic quantum number. It's explain the effect of an orbital in magnetic field, that is orientation of an orbital, how an orbital orient. An orbital split up into its degenerate orbital having same energy and size in a magnetic field. Each degenerate orbital can hold up to 2 electrons. So if L is or lambda is equal to 0, the shape of the shell will be S. Lambda is equal to 1, P, lambda is equal to 2, D, lambda is equal to 3, F. So the values of M for S0, P minus 1, 0 plus 1, like this manner it will go on. So we know an S subshell can maximum carry 2 electrons. P subshell having 3 degenerate orbital. In each orbital it will carry 2 electrons. So totally 3 orbital, 6 electrons. Similarly for D it's 5, so it can hold up to 10 electrons. And spin quantum number, how the electron spins, either clockwise or in the, like this manner, or anti-clockwise. And another important question you can expect from this part is differentiate between orbit and orbital. Orbit means the principal quantum number, that is, it is a path around the nucleus which the electron revolves. It is the path of the electrons where it revolves. It's about the revolution. And it may be circular or elliptical in shape, and it represents the movement of electron in one plane, only in one plane. But in the case of orbital, it is the region around the nucleus where probability of finding electron is maximum. Actually, we cannot predict the exact position and momentum of an electron. Which principle is this, children? It is Heisenberg's uncertainty principle. So based on that, we cannot find the exact position of the electron. So we can say only the probability. So orbital is the region around the nucleus where probability of finding electron is maximum. It may be spherical, dumbbell or double dumbbell shape. For S orbital it is spherical shape, P orbital it is dumbbell shape, D orbital is double dumbbell shape, etc. And such type of questions also you can expect.